We are team 19031, and we have designed and created the short wavelength infrared transmitting optical beacon for our sponsor, Elbit Systems of America. And since we don't have the pleasure of meeting you all face to face, let's go ahead and do a virtual introduction. So here's our team picture. Starting from the back left, we have Colt, then AJ, Alex, myself, Jared, and Ryan in the bottom right. And here we have the overview of our whole poster and everything that we've done with our mentor, Mr. Gilblom. And we're going to go ahead and turn the introduction over to Colt.
All right, thanks, Jared. I'm going to get started with the introduction here, and we'll begin with the project goal as given to us by Elbit. And we needed to develop and deploy an infrared beacon, we call it strobe for short, to identify a target or position in the field. And what we made was a handheld device. It's rugged enough to work in all conditions and environments. It's going to be thrown out and viewed by anybody who has the proper night vision equipped. It's a cell phone type shape with two emitters on either side, top or bottom. It's remote controllable, up to 3 units from one remote control, and it can survive drops well above 6 feet. It can be reused, and it can have enough energy to be powered continuously for well over 30 minutes. Looking at the system block diagram, we have two external interfaces, the remote operator and the night vision equipped personnel. So the operator is going to start it off. Inside, you can see all of our subsystems. They'll be talked about further in the video, but just a brief overview, we have power, we have our shell, we have our controls, and we have our optical subsystems. And I'm going to turn it over to Alex. He's going to get more into the weeds.
Thanks, Colt. I'm Alex Valencia. I'm a mechanical engineer on this project. So as Colt just recently stated, there are 4 main subsystems of this main device. The first is the optical assembly. This consists of a 500 milliwatt laser that shines through 5 lenses that will create an optical cone of light in the infrared spectrum that can be seen by anyone with night vision. We have 2 of those positioned 180 degrees apart. So when the beacon is deployed, it will land on one flat side, and no matter what flat side it will land on, an accelerometer will make sure that only that light shines up. This is all controlled by an Arduino Uno, which is the brains of this whole operation. Within the Arduino Uno is the accelerometer and a component so we can wirelessly interface with an outside controller that will control up to 3 devices at one time. This is powered by 2 sets of AA batteries, 6 in each set for 12 total batteries delivering 6 watts of power to the entire device. All this is encased in a 3D printed 2-piece nylon case that can withstand impact up to a 6-foot drop onto concrete, and was tested and succeeded in all of that. And I will turn it over to Jared for the results.
All right, thanks, Alex. And as stated, I'm Jared Mars, one of the electrical engineers. Just to give a brief overview of the results, we were not able to test any of the optical components due to the coronavirus closures. But in summary, we have passed everything else, exceeding our expectations. We were able to get continuous wave, pulsed frequencies, no power variance, or at least from our LED. It's stationary at a 45-degree angle, very rugged, survives the drop, and really has any lifespan as long as you're performing within the specs given. I could see this going on for many years and still being able to work. And then the rest of the requirements we'll go ahead and turn over to AJ.
Thanks, Jared. Again, I'm AJ Ferentz. I'm another electrical engineer over here on the team. And yeah, for our project, we were able to have all of our beacons powered by AA batteries, which fit that requirement. Our LED version was able to operate for 10 hours on those batteries, and our laser diode version, we estimate will be able to last for 3 hours. For the outside dimensions of our case, our LED case and our laser case both made it within the 5x5x5, with our LED one being a little bit thinner. And for size and weight, our LED one came in at 1 pound, which is well under the 8-pound limit. And for the overall project, we spent about $2,500, and so we are under the $4,000 budget. Moving on to the conclusion, our strobe was a huge success. All 3 beacons were able to be created and tested in the field, and we were able to ensure full remote operability, and we were able to mark targets in the field. Moving on, I'm going to go over to Ryan.
Thank you, AJ. I'm Ryan Bunyard, the Optical Engineer, and as aforementioned, the COVID-19 pandemic did not allow me to do any tests on the optics due to closures. However, we did receive all the optical components, and we weren't able to integrate them to do any of the testing because all of the materials needed were in the College of Optical Sciences and the labs were closed, so I was not able to do that. But with everything integrated, we would expect the shortwave IR beam to be 1550 nanometers, according to what we had for the laser, and all of the requirements met, so at least 120 full field of view, 120 degree full field of view, less than 20% variance in the wavefront uniformity. We expect it to be eye safe based on calculations with the laser diode about half a foot from the final lens.
Here are 3 strobe optical beacons, each controlled by their own potentiometer on our controller. By turning the potentiometer, you can start the LED and blinking, and you can control each one remotely. Each beacon is equipped with LEDs on both sides that will activate when facing up or down.
Our beacon is on and it still remains operable. I should be able to turn it down all the way to the off position or turn it back on at whatever frequency rate I like.
I just wanted to give a quick shout out to our sponsor, Elbit Systems of America, for just being really responsive and helpful to our project. Dr. Dale Hetherington, who's one of the faculty here, and our own mentor, Mr. Gilblom, and all others who are involved in making this project successful. And just wanted to say thank you for all of that, and thank you guys for watching.